Welcome to this ATA Insights webinar. Thank you for your ongoing interest and support of our webinar program. Today's session will begin in 2 minutes. ATA Insights Webinars is an online platform for the dissemination of professional renewable energy knowledge across international borders. Our aim is to democratize access to information, for innovation to spread faster, and to make the industry more competitive. And we do this through our online sessions, open to all our members. Every year we do more than 100 sessions with over 250 speakers, 50,000 attendees from more than 50 countries. To participate in the session today, use the chat on the right-hand side to introduce yourself, your company, and where you're joining from. Under the screen you will find the Q&A box, where you can send your questions for the speakers. We will get to as many as we can today. We're recording this session and we will send you a link to the materials in a few days. Please consider supporting our content creation for the webinar program. Contact us on the email on screen.
Hello, good morning or good afternoon, depending on where you are connecting from. Welcome to this ATA Insights webinar, which, as you can see on screen, is about maximizing production and protection algorithms to consider for your PV plant. And today we have 3 experts with us who'll be talking about this topic. And well, you know, in a few seconds, I'll let them introduce themselves. But before that, I'll repeat some of the things that you just saw in the video. So we'll definitely be recording this session and we'll send it to you along with the slides after a few days after the webinar. So right. So well, I think I'll start with the round of introductions. So let's start with Mireia. Mireia, if you could please tell us a little bit about yourself.
Hi, nice to be here. Well, I'm Mireia Jiménez. I'm product manager here in Soltec, and I'm focused on the product part, from the tracker to the algorithms.
Thank you very much, Mireia, and welcome to this webinar. Next up, Emilio, if you could please introduce yourself briefly.
Hi, thank you very much, Carlos, and thank you to ATA for organizing this webinar. My name is Emilio Marconell. I am the operations director for Soltec. Sorry, apologies, for Powertis, Soltec Group. And I support all our countries, our developments, and also I am based in the US and supporting the development activities there.
Thank you very much, Emilio, and welcome to today's sessions. And Álvaro, if you could please introduce yourself briefly and get ready to present, because you'll be the first one up.
Well, yeah, good afternoon, everyone. My name is Álvaro Sánchez. I'm the Iberia Engineering Manager for StarCraft for wind and solar for Spain. I have been in the company 8 years, mainly doing EPC, and I'm going to try to do a view of the EPC for this very interesting topic that we are going to talk this afternoon.
Great, thank you very much. I'll stop sharing my screen so you can share yours and start presenting. And in the meantime, whilst you're getting ready, I'd like to remind everyone at the audience of the tradition we have at ATA Insights, which is that everyone in the audience just say where they're connecting from. I'm actually today connecting from Berlin, which is warm today, which doesn't happen very often. And the other thing is that remember that you can send questions through the Q&A box. Okay, so without any further delay, please, Álvaro, go ahead and deliver your presentation.
Okay, can you see my screen?
Yeah, I can see it perfectly.
Good. I'm going to try to give an overview about the company because it's not very well known on the renewable industry, especially on PV. Okay, let me try. Okay, so yeah, StarCraft owns basically 18 gigawatts of renewable installed capacity. We have over 4,800 employees over the world. You can see on this map that we are mainly based on Europe and also South America. We are also, this is good to mention, that we are the Europe's largest producer of renewable energy. You can see here that we have produced during 2019 almost 60 terawatt hour of renewable energy. This is mainly because of the hydropower plants that we own on the Nordics. You can see also some reference that, for example, we have produced double than, for example, Iberdrola or any other very well-known companies. It's also very worth to mention that we are 100% owned by the Norwegian state. So it's run by the Norwegian state, the company. And also we have 340 power plants around the world. And yeah, we produce what I mentioned before, that almost 70 terawatt hour per year of renewable energy. It's also good to mention that I said before that I'm going to try to give here a view from the EPC point of view, but also we are involved on the whole transition of the project. So we start the project, we get the project since it is a greenfield. So we work on the development of the project. We do also the construction only of our own developed projects. We do the EPC, and also we do the operation. So we do asset management, operation and maintenance, and also we have another team that is called markets, and they work on the PPAs, green certificates, and other optimizations. So yeah, so moving into the topic that we are talking this afternoon, this picture is very self-explanatory why it's so critical and why it's so important to make everyone aware about this topic, that it has been progressed a lot during the years. But for example, when we moved from the EPC, doing EPC in UK and Netherlands, and we moved to Spain, we started to build trackers, and one of the most worrying things was to have a moving part on the solar farm and all the issues that you can have with that. So since the first days, and we started Talayuela, the 300 megawatt that we built in Extremadura, we started to look very carefully about the tracker design. So I have prepared 2 slides for these topics. The first one is regarding the first one is about how to protect your trackers from weather conditions. So maybe some of the topics that I will go through this afternoon are very well known or basic for everyone, but I think it's good to do a summary of all of them. So the first one is that, okay, you can protect your tracker, but the first thing that you need is to have a very solid and very well designed tracker. So the first point that we always look is about how is the structural design done by the tracker supplier. And one of the first things that we look, and everyone has to look and be aware of that, is the wind tunnel test. I think Mireia is going to go through into the wind tunnel test in more detail, but it's true that since the last 3-4 years, it has evolved a lot. So now some people is doing a full aeroelastic model, which it was not even thought a few years ago. One of the other things also quite critical that we have seen is that this structural design check has to be done ad hoc for the project. So not every project has the same. Even when you change the size of the module, the tracker configuration totally changes. The inputs that you have from side, like the wind speed, snow load or hail that you have has to be very well looked, and that has to be implemented on the structural tracker calculation. You cannot do a structural tracker calculation for your whole pipeline. It has to be done for every single project. It's also worth to mention that in general, the tracker suppliers, they have quite different trackers. So every tracker has to be looked separately and has to be looked properly into that. So sometimes you have like external trackers, internal trackers, they have different loads, sometimes different configurations. And one of the last, let's say, specific points that we have seen on the design is the slope. So for example, we have sites where the slope is about 12-15%. So it's also worth it to check how the wind is impacting on the trackers where you have high slope, because obviously it's not the same to have the tracker flat than the tracker with a slope of 12, 15 or even more. To do all of that, we don't do it in-house because we don't have enough resources, but we always do a third-party validation. So we have a short list of companies. There's 3 companies on the market that we have validated them to do this check. It's also important to mention that this is not just the review of the tracker, the calculations done by the tracker supplier. is a validation done totally by them. So they basically build the model, they build the tracker, and they check everything. Is like they redo again the structural calculations based on with the inputs from the tracker supplier, and also they also check the inputs, and also they check also the inputs from the wind tunnel test, and also the design of the tracker. One of the and also it's worth also to mention that this third-party validation used to take 2-3 months. So in general, it's not easy to accommodate on the procurement process, but we think that is mandatory, at least for us, and we always include it. Also, the last point regarding structural design check is also the modular strength. That has to be decided carefully, because now we are part of the IC committee, and we know that there is now a new trend on the module suppliers that as they have to cut the cost. One of the points that they are trying to cut the cost is to do different the same module, let's say physically, but it's different that can withstand different loads. So like to have one type of module for the internal tracker where you have lower loads, and another different module for the external tracker where you have higher loads. So it's also a new trending topic. To have I think it's important to have a good tracker, but also you need always when you are talking about issues, you need to have a very good insurance. So how the insurance is negotiated, this is quite key, but that's done by another department. But we need to be careful that if something happens on the solar farm, you will have you will be covered. So one of the things that we have implemented since the first project is always to record the weather conditions. So we have implemented in our technical specifications that when you start to build the first project, the first module, when you install the first module, you need to have recorded all weather conditions, basically the wind speed, wind direction, and also snow. Because if you have any issue, you need to have something to prove that the insurance has to cover yourself, because they can otherwise say, okay, it's a misinstallation, or it can be any other issue. They are going to try to cover themselves. Also, regarding this topic, it's also important to say that the design, we always do the design according to the standards, because obviously we want to be safe and we don't want to open any discussion with the insurance. But it's important to see that this is the map for the wind for Spain, and you can see that the zones are very big, and you know that the wind speed in, let's say here, that is Talayuela, is not going to be the same than, for example, here that is Bienvenida. So we consider that it's very broad. We always do our own hail study, and also wind study specific for our site. But afterwards, we do the design according to the standard, just to be covered. And in case that we have any issue, we can also prove that we have done the calculations according to the standards. But in general, the wind speed for the sites, we have seen that is lower than on the standards. And also something very important for how to protect the tracker is that the tracker has to be smart. So I put it here: make the tracker smart as possible. And so the first point is that the tracker obviously has to be able to detect the wind speed and wind direction, which is looks like quite basic, but we have seen that sometimes the tracker that doesn't know from where the wind is coming and is not able to protect itself according to the direction. So this is something that we have also implemented on our technical specifications. So the tracker needs to be able to know from where the speed is coming and which is the speed, and act consequently and go to stop position or go to any position to be safe. The power supply also is very key to be designed. Obviously, if you have a tracker very smart and doesn't have any power, it doesn't make any sense. So you can have the possibility that at some point the tracker run out of power and the tracker is in a position that is not safe. So if you have, in that case, very high winds or any other weather conditions, the tracker can be broken, and obviously you're not going to be covered by the warranty or nor by the insurance, because it's a mal design of wrong design of the power supply. One of the latest topic, because we are building also a project in the south of Cádiz, and we have, according to the standards, we can expect very high hail. And so this is something quite new for us. We have been talking with the module supplier. They mentioned this IEC, the 61215 of the 2016, and basically this standard is the standard that the module suppliers use to check how much load the module can support. So we have seen, just this is like the internal conclusion, but the module can support up to 40 millimeters diameter ball or ice ball with a very high tilt. But the tracker needs to be able to understand that you have hail and needs to go to that position. And according to the standard, the module can support 25 millimeters without any problem. But this is the picture that it was shown on the latest IC. And you can see that the big damage that you have on the modules. It's true that this project is a fixed tilt. So anyway, the fixed tilt cannot do anything. Also, just to mention at the end is just the tracker needs to be able to detect the snow and act accordingly. So you have high snow, the tracker will know, and the tracker will get tilted just to drop the snow from the top of the tracker. So that's why one of the most important things that I have mentioned many times on this slide is the technical specification. So we have, as StarCraft, we have very detailed technical specifications. We are always updating when we know or we discover something that has to be implemented. And this is mainly because there are not solid standards yet. The second point of this, the second topic is that the irradiance optimization. So just to see how we can get the most of our tracker, because obviously we have a tracker is mainly to improve the production of the solar farm. So the first point that is very well known by everyone, and I'm going to discuss more, is the backtracking. So now all the trackers on the market, they have backtracking, but it's also quite important that you do an ad hoc backtracking setting for every individual tracker. So you have to get on site all the coordinates and the height of every tracker, and configure that on your SCADA. And also the tracker needs to know the coordinates and basically the location and the height of the neighbors, so it can add according to that. Something also quite important that I mentioned here is to use always the TMY database for calculations, because when we have used the synthetics or any other ones for the trackers, it didn't work very well, and we have seen very big difference. So sometimes the TMY is expensive because you need to pay for that. It's not free in general, but I think it's worth when the project is getting solid to do it, because you can have an impact of 7%. One of the also trending topic now is the diffuser irradiance optimization that most of the tracker supplier has implemented. Also Soltec is here. So this is basically that when there is no much direct irradiance, when you have like a cloudy day, the tracker will go to almost flat position in order to get more diffuse irradiance, because it will produce more than just trying to optimize the direct irradiance. So that's why the main thing is that the tracker SCADA needs to have all weather information. A part of the weather information that the tracker supplier will install, also the or any weather station that you have on site, it is good to give the data to the tracker supplier, so it can add according to the machine learning. The last point is the research and development. Is something that we are investigating with a prototype that we are doing in Italy with the University of Bari, and it's a module rear shading. So it's also okay. We can optimize the tilt of the tracker according to the diffuse irradiance, but it's also worth to see how is impacting the rear gain when you have different tilt. The next point is also quite important according to our experience, because it's true that you can have like a very solid tracker and very like a Ferrari tracker, but afterwards, if when detects some wind, it goes to stop position, you're not getting the most of that. So we have seen that some tracker suppliers, they did do a design with a very high wind speed, but when the tracker detects low wind, it goes to stop position. You have to know that when the tracker goes to stop position, it's not on the optimized tilt, and you will lose irradiance. So this is also something that we have included in our specification very carefully, to have steps and to have steps also of wind speed and also steps of tracking range. The next point is just to mention that is important in order to optimize your design to choose the right tilt angle, because some people is going to plus minus 60 just because it's what is included on the datasheet, and you can think that doesn't have any impact, but it's true that has a big impact, especially in the tracker design and also on the price of the tracker. So for example, we in Spain, we used to go to 55 or sometimes even 50. So the tracker, let's say the the center of the tracker is closer to the ground and is more stable, and also is cheaper because you don't need so much steel. And the last point to include, that is also included on this research and development project that we are doing, is the machine learning with inverter. So it's a new topic that the inverter will act as a brain for the tracker, and it will move the tracker according to the radiance that you have and according to all the data that they have learned, and in order to optimize your production across the year. And I think that's all. Thank you for your attention.
Thank you very much for your presentation, Álvaro, and everybody who is all of you who are in the audience. Just send any questions that you might have about Álvaro's presentation. We'll get to it after all the presentations have been delivered. And next up, we'll have Emilio's presentation. So, Emilio, whenever you're ready, turn on your camera and start sharing your screen.
Thank you very much, Carlos.
You're welcome. So, yeah, I can see it perfectly. So, over to you.
Perfect. Thank you. Thank you very much. As I said, my name is Emilio Marconell. I am the Director of Operations for Powertis, part of Soltec group. Soltec is a vertically integrated group of companies based in Murcia, Spain. We have there our R&D, manufacturing and distribution center for, and we send our product worldwide. Soltec has been in the industry for 18 years and has a track record of 12.7 gigawatts, and the main markets are in the Americas, in Europe, Africa, Middle East, and Australia. Just briefly talking about Powertis. Powertis is a large-scale utility, large-scale utility solar developer. We have a strong presence in Europe and the Americas. We have a balanced portfolio of 11.6 gigawatts under development, 225 under construction, and 5 megawatts in operation. We are present in 8 countries, and we have an 85 employee team. And something very important for us is that we control the entire project value chain, using trackers and construction services provided by Soltec. So this is just an indication of where the markets we are and the volumes that we are achieving in each market. But today, what I'm going to discuss is about how we optimize generation, okay, from the development point of view. And in order to do that, we analyze this. We have a very careful analysis of technology and design. Based on that, those two factors have an major impact in LCOE, which is the levelized cost of energy throughout the life of the project. And as you can see in the formula, what we do is trying to maximize generation, which is the denominator, by controlling or optimizing the numerator, and that's how we like to approach our projects. Again, I said that we were looking at different technologies. If we start with modules, we have seen in this year, in 2022, how after a while, module manufacturers have decided to release new technologies. For the last few years, they were focusing mainly in getting larger and larger modules, but without really changing too much, just without changing or increasing efficiency. This is changing. For the last 6 months, we have seen very active movements in the industry. PERC, which was the traditional, at least has been for the last 3 years, the most common module, It's obviously it's the cheaper right now. It's the most common. Has the smallest efficiency when compared to the newcomers, but also the lowest bifacial. So we have nowadays, Topcon and heterojunction coming strong. Most players are already positioned themselves. Some of them even they are positioning both technologies. Topcon is more in the middle point, and heterojunction provides a bit higher efficiency, a bit higher bifaciality, but it's a bit more expensive also. But with regarding the LOC and what is worth it for us, like if you asked me this 6 months ago, I would probably say, yeah, PERC is not an option. Today, it's not so clear. Now I would say that at least as we analyze every single project with both all technologies. For some, we are seeing that for some projects, it's worth it. For us, it makes a difference going to N-type modules. That's no doubt that this is happening right now. If we talk about the structure, we always work and analyze both options, 2P and 1P. At Soltec we have both, and I still think that 2P for me is a better technical solution, especially because for the Soltec project or tracker, the SF7 has a gap in between the two modules. That gap makes a huge difference in terms of cooling effect and real shade, because the torque tube will not be doing any shadings in the rear side of the modules, especially now with most of the modules are bifacial. The problem with 2P right now is that, of course, it has more steel, and now steel is extremely expensive. So that's why I was saying, it's better, it's worth it to analyze both projects and see what tracker will fit better for a specific project. Of course, in both cases, 2P or 1P, they must, and Mireia will speak later about this, they must have validated algorithms. Soltec works with third parties that validate those algorithms. It's extremely important for protection, diffuse buster, and backtracking. That's a paramount. That's something that we cannot miss. Regarding the inverter, the traditional approach has been like smaller utility scale projects went with a string, like larger, like I don't know, like 40 or up. Normally went with central. This is not the case anymore. We are seeing projects like 100 or even more megawatts that are being done with the string inverters. Again, we recommend to analyze this case by case. The reason for this, that the string is catching up also for larger projects is because, although it's a bit more expensive in terms of capex, for opex is more convenient to use strings. It's more like plug and play. Easier to change if there is an issue. If there's an issue, whatever is blocking or whatever is stopped is minor compared to central. Although the centrals are also learning from this and are using now modular designs. But any case, it's worth it to analyze both options. And on ours, for us, it's not a clear winner. We always recommend to analyze both. The pitch, regarding the pitch, and that this is more related to the design. It's important to consider, and especially now with bifacial, that it's important to have larger pitches that we used to have with monofacial. It's important that there is more space in between the trackers for the light to reflect, and that goes straight to the light that is coming to from the reflection from the air from the surface towards the back of the side of the panel, but also diffuse. It will get more diffuse. So that's very important to make sure that you have a decent pitch. And in that table below, we have that how this is done for an SF7, which is a 2P. Like a difference in 2 meters in pitch from 10 to 12 would increase generation by 2.5%. So it's very important to consider. Well, this CAC, again, we are talking about design now. It's not about here the way we approach projects is not about maximizing just maximizing for the sake of maximizing the generation. If you have a really high DCSE, for sure, your generation max is higher, but not always is the right thing, of course, because then yield will reduce for sure because clipping will increase. So again, what we normally do is we do several exercises. We can do 1.15, 1.20, 1.25, 1.30, depending on how the albedo works for the specific project. We get a set of over builds, and that we normally work for 3 or 4. And yeah, basically, just to finalize, when we do the PV Syst, what we like to consider is, long-term databases. It has been said before. Meteornorm, it's the default, but sometimes it pays off to pay some other databases, which would be a bit more accurate. And normally, not always, but normally we'll get higher returns, higher GHAs. Thermal model is important, and this is something that PV Syst normally works with 29 and 0 as default, and in UC and UV. This is not real. That would consider that the wind is not affecting at all in generation, which is not true. Wind has a cooling effect. But in order to use a specific thermal model, it has to be validated by a third party. Otherwise, advisors or banks will not take that into account. Same with rear shading. Again, if you're using a 2P, for example, with a gap in between, that's going to benefit the rear shading as it will benefit the thermal model. But again, you will need some kind of a third-party validation for that. Albedo is important also to consider. So a campaign is nowadays is a must because it will have an impact. Again, as I've been saying, nowadays, at least in our case, all our projects go with bifacial. And finally, IAM. It's also important to have a look there because we see that for different manufacturers, and when we run PV Syst, we see a huge variance of IAM losses from 0.9 to 0.15. So sometimes what we always ask the manufacturers to provide like third-party validations of these values, so to make sure that we are consistent, and when we compare different modules, we're using a clear level comparison. And this is everything on my side. I'm happy to answer any questions that might have anyone. Thank you very much.
Thank you very much, Emilio, for your presentation. As Emilio said, you can ask questions. So if you have any doubts, don't stay with them. Send your questions through the Q&A box. And well, next time we'll have a presentation by Mireia Jiménez. So Mireia, whenever you're ready, yeah, I think Emilio, you need to. There we go. Yeah, I can't see your presentation, Mireia. So over to you. You're still on mute. Okay, not on mute. No, go ahead.
Hello, everyone. Well, thanks, Ata, for giving us the opportunity to present our work here because, well, there's a problem when it comes to maximizing the production, and there's conditions, as Álvaro mentioned. Soltec is a leading solar tracker manufacturer. At this moment, we have more than 16 gigawatts of trackers with contracted and ongoing projects, and we are developing our own projects all over the world. We have more than 1,300 people working at Soltec and also its subsidiaries, and we have offices all over the world. Soltec's history goes back more than 15 years. We started in 2004 as installers, and then in 2007 we developed the 10K5 tracker, a dual axis tracker that already incorporated wind and hail protection algorithms. In the case of hail, the tracker moved the panels vertically to avoid any damage. Since that first tracker, we have evolved our products a lot, going through the SAE series, which was multi-row, then the first solar fighter for residential use. That one helped us to use the tracker technology in the sub-utility, the first 2P tracker on the market. And since then, we have been optimizing the product and diversifying our portfolio to offer our customers a wider variety and to be able to adapt to their needs. The last one was the SF1. It's a dual row 1P tracker, and it was launched last year. While the production of the solar tracker is maximized, it is important also to ensure that the tracker remains in a good condition during the working years. For this reason, proper design is a key factor, but also the algorithms used during the operation of the PV plant. I'm going to be very brief with this. Álvaro mentioned the wind tunnel, but I think it's also important to understand that part, the key part of the design, that it's the first method to avoid any damage during the operation of the plant. And I want to show here a brief evolution of the industry in terms of the wind. Soltec has put a lot of effort in understanding how the wind affects the trackers and see all the possible optimizations without putting the structure at risk. Since before 2015, already in 2013, 2014, we started with rigid wind tunnels with a maximum chord, that is the tracker width, of 4 meters. Then we incorporated sectional wind tunnels to see the critical instability speed and also the aeroelastic effects of the wind. All of this led us to the die-wind methodology developed with RWDI. They are experts in wind consultants. They are wind consultants. And well, to consider all the dynamic wind loads and aeroelastic instability limits based on the buffeting and fluttering of the tracker, what we see here as BAM and FAM. In 2020, with the results of the die-wind, we made an aeroelastic wind tunnel that we can see well here in the video. I don't know if it's a great video, but well, in the video we can see the behavior of each tracker according to their position within the layout. And with this, we use a database both in 2D and 3D with the calibrated CFD simulations to calculate all kinds of scenarios. The video just stopped. We see an example, let me see if I can run it. An example where we analyze a hybrid stow situation, for example. The idea is to have a database that includes tracker widths from 2 to 5 meters, different tracker distances in east-west directions, I mean the pitch, also the different lengths, even the use of dampers. Okay, so it's all kinds of parameters that we face in a particular way in each project. So we are developing this huge database with a whole of scenarios with different slopes and different parameters. In 2020, well, 2021, we updated the wind tunnel test to adapt the new wider and larger modules formats, and we started with the validation of the SF1 version to incorporate also its coefficients to our die-wind methodology. For this process, we joined CPP Wind, that's another of the largest wind expert consultants in the world, with an extensive experience in 1P trackers. And today, we have already incorporated in our calculation model. This process of including this SF1 version was very fast for us, a matter of months, thanks to all the knowledge and all the resources that Soltec has put in the last years in these fields. Well, as I said, the proper design is a key factor to ensure the reliability of the trackers, but it's also important the algorithms used during the operation of the PV plant. Well, at Soltec, we use ultrasonic sensors to take into account not only the speed, but also the direction of the wind. This, together with the position of the tracker at the time of the alert, will lead us to decide the best defense strategy to protect the tracker without penalizing the production. It is also important to understand that the trigger speed can change depending on the wind directionality in order not to penalize the production. In addition, different values are taken from the plant to track the gas speed to decide if it's necessary to go to the fence position. At Soltec, we have been improving the wind algorithm for years, as many years as we have been with LWDI, more or less. And for example, about the hail algorithm in Soltec, it is used since the first tracker, the 10K5. You can see here an image on the right side of the slide. This is a vertical position of the modules to avoid any damage of the hail. There are other algorithms for snow, flood, even thunderstorm, but that brings us also to the algorithms related to the electronics and communication system. Within the electronics, we will have, if any operators activate the stop button, if there's any failure in the communications, if there's low battery, or if, for example, there is an overcurrent or an under voltage in the motor. Motor overcurrent algorithm aims to prevent the motor and battery from breaking and to try to get out of the stack position. If the tracker, for example, in the case of the snow, there's a snow barrier, the tracker tries to move, but the snow it's frozen, then this protection, this motor overcurrent algorithm stops the motor to prevent to break from that position. And also the motor under voltage algorithm is intended to protect the battery, the electronics and the motor, since prolonged movement of the tracker at a voltage below the recommended voltage may cause also breakdowns. Now, for the maximization of the production, TeamTrack firstly assures secure tracker plant operation independent of external communications and provides secure remote data communications. We've adapted the algorithms for both independent and URO, and the TeamTrack 3D algorithms use NREL sun position data versus program constants of local irregularities to execute energy optimized backtracking position control, avoiding inter-row shading and achieving a yield gain. Tracker control is simply configured with irregularity parameters that do not change with time or external influence in normal operation. TeamTrack stands out from existing solutions that add equipment and feedback response mechanisms that add cost and vulnerability. TeamTrack also enables cost reduction in earth grading or contours and steps, because it has zero maintenance as well and provides for hardware independent software updates. The results for the case of a regular terrain in the Mediterranean latitudes are presented here. For example, three strategies of backtracking have been analyzed with Tube Rayland to get the results that you can see here. So Tube Rayland verified that our algorithm obtained 6.2% more energy than standard tracking in regular terrains and average latitudes. And the optimization compared to the standard backtracking, it's 2.3%. Furthermore, the study concludes that compared to the standard tracking, our algorithm obtained between 3.6 and 7.5%, depending on the terrain and climate conditions as well. If a comparison is made to a standard backtracking, annual optimization ranges between 1.2 and 3.5%, more or less. But again, the algorithm gains depends on terrain irregularity and also to the latitude. Also, with Tube Rayland, we verified our Soltec diffuse booster algorithm. The objective of this algorithm is increasing the production of the PV plant even on cloudy days, meaning when there is more diffuse direct irradiance. The algorithm which uses both sensors and weather forecast moves the tracker to the optimal position that captures the maximum irradiance This way, the algorithm increases production of cloudy periods by 5–6% depending on the latitude. Diffuse booster is one of the algorithms that make up the Soltec team track extended package, which aims to make plants smarter so that they can anticipate and orient themselves in the most profitable way. And well, how this work? Tracking system have to include the diffuse energy neutralization functionalities. The graph here shows the performance of this function compared to the standard astronomical tracking. To a representative, this is a representative day in which the sky gets cloudy. Early in the day, the sun shines, and well, therefore the tracker maintains the orientation to the sun. As the clouds appear, the irradiance of the oriented plane decreases considerably, fluctuating as the sky gets overcast, and horizontal plane irradiance exceeds steadily oriented irradiance. The lower graph shows the middle one here. Shows that period, the angle of the tracker in the astronomical tracking remains oriented to the position as shown in the center picture below, like here. And whereas the tracker with the diffuse booster active remains horizontal to the optimized energy and capture all the celestial sphere irradiance. Okay, as you can see in the last one here. Energy collected by the tracker in optimization mode exceeds in 94 hours per meter square, achieving a daily generation improvement of 1.4%. Here we see a comparison for an example of a fully cloudy day. Tracking with active diffuse booster increases capture irradiance, improving full day power generation in 12.4%, offering even instantaneous improvement peaks of 29%. The implementation of the team track, including basic team track and the diffuse booster, algorithms may raise the year energy yield up to 6.3% in Mediterranean regions. Again, this depends on the latitude, depends also in the regularity of the terrain. It needs to be analyzed in each project. And well, here for the smart tracking, again, you need to also to be sure that you will have, well, that you are adding all of the algorithms that you can when we talk about trackers. So here we say, well, this is just a particular case for this for this scenario. So if we consider that for a specific case, we can have a bifacial gain for using bifacial modules of 8% more or less. If we add basic backtracking strategies to avoid shadows on the front face during sunrise and sunset, we can reach more than 12% gain. To all of this, Soltec, what we propose is to use a package of algorithms that optimize the electricity produced depending on the diffuse radiation, bifacial parameters, or even the module temperature. In this case, for example, the total bifacial gain was around 15%. And to be able to monitor, to monitor both security parameters and algorithms, it is necessary to have a good tracker monitoring system, what we call TMS. Our TMS is part of our full wireless system with distributed control, which makes the system more reliable. It's able to detect anomalies and also with alarm management for the operation team. Well, here PV plants are often exposed to hazards that put the installation at risk, becoming an unpredictable economic investment. The tracker design must consider the aeroelastic effects caused by the wind, and the Soltec trackers have always the day wind implemented to make sure about this. Also, the electronics integration, it's also required to face weather phenomena. And while priority management in algorithms is key and can make all the difference when it comes to optimize PV plants' performance and protect its integrity in case of unfavorable weather. While team track tracking, it's always enabled, And there's an optional additional algorithm package to consider diffuse radiation, bifacial parameters, and also module temperature. That's all. Thanks. And if you have any questions, just let me know.
Thank you very much, Mireia, for your presentation. So, well, as you could see, there are various ways in which you could optimize the performance of your plant and protect it. So if you have any questions, send them through the Q&A box. I have a few questions of my own. So, are these algorithms location dependent? So do they work differently, or can they be adapted to different locations, geographically speaking?
Yes, I mean, it's important to understand that depending on the latitude and even of the topography of the site, the improvement that you can do, it's going to be very different. It's not the same having a flat terrain. So if you use a regular backtracking, probably you won't notice that the improvement with the team track backtracking. You will notice something, but it's not that much if the terrain is super flat. But if, for example, it's a very uneven terrain, like the ones that we have usually in Spain, then you will notice that difference because we analyze the slope of the different locations.
Mm-hmm. All right. You mentioned that you could get an improvement, if I remember correctly, in one of your last slides. You could get overall an improvement of about 14% in performance. So have you run calculations of what that means in terms of revenue for plant operators? Because, well, maybe you haven't, you don't have it at hand, but I think that would be interesting for those who are considering deploying this type of system.
I mean, we have done some economical models to analyze that, but it's true that usually it's something that our customers do. People like, for example, Emilio for the developers part, or even Álvaro from the EPC, sometimes they do these, they put these numbers on their models to get that revenue.
Yeah, all right.
Yeah, of course, Carlos, just
go on, Emilio, yeah.
Yeah, comment here for sure. An increase in generation because of these algorithms. That's I mean, impact directly to the revenue side of the business model. So yeah, of course, it's a massive impact. It can be really important.
Right. Yeah. No, that's I can imagine. So I was actually thinking as well. So there are different ways you could configure your tracker. Does the algorithm adapt to different configurations? So how does it work?
Yes, I mean, for example, in our case, we have an independent tracker, and then we have the dual row. Our team track, it also has been adapted to the dual row version. Obviously, it's going to be slightly different. You will get more benefit in an independent row, but there's a benefit also in using it in the dual row because we already adapted to avoid any shading in that case.
All right. And well, I was gonna, go on with a question for Emilio, but I see a question from the audience coming through. So let's answer that one first. Is Giorgio Figuera asks, question for Mireia, Soltec's algorithms purely data-driven train on historical data, or do you need to reconstruct a model of a PV plant?
Well, for example, for the team track, for the backtracking, it's during the commissioning that we analyze the position of each tracker to be fully adapted. The other ones, for example, the diffuse booster, we use also forecast and also the sensors that we have in the PV plant to see what it's best to do.
Mm-hmm. All right. So, well, moving to another question that I had. So, Emilio, you mentioned in your presentation that there are different module technologies. So you have TOPCon and heterojunction, or HJT. So which one do you see as a winner in this race?
Well, thank you, Carlos, for this question. I think it's a good one, really good one. And nowadays, I would say for the very short term, maybe I would go with Topcon. For the medium, I might go for heterojection. We have to see how the market evolves. Right now, the reason I'm saying this is that Topcon right now there is more capacity in the market right now. It's the transition from PERC to Topcon is easier, so manufacturers can use the same lines. That meaning that there is more capacity in the market. It's true that you could get some extra generation with a heterojunction. At least that's at least what the analysis that we are doing right now. But it's also a question of do you have enough capacity right now of a heterojunction? So yeah, short term, I would say Topcon, maybe 6 months time, things might change and go towards a heterojunction.
Right. Well, we'll need to keep an eye on the market then. I don't know if any of the others want to comment on this, or should we go to the next question? No. Okay. So, well, I wanted to ask you, Álvaro, about the diffuse irradiance optimization. So, what kind of gain could you expect to gain from optimizing diffuse irradiance?
Yeah, so that depends a lot on the location of your project, because obviously if you have a cloudy weather, it could be UK, you will have more gain, but in UK you don't install trackers, so it's not a good example.
Yeah.
But yes, as also Mireia mentioned, is that the gain could be like 6-7%, but on the region where I'm working, that is basically Spain, we have seen the best gain according to this optimization. We have seen it 2% according to the PVC's calculations, and that's also worthy to mention that you need to always use the TMY database to take into account this, because otherwise the synthetic GR is it can make a big change on this, because the synthetic GR could not be very, very realistic, and you can have a lot of clouds, and maybe that's not real for your location.
Right. So there is a question actually on the diffuse booster on the Q&A box. So Gonzalo Lacerna asks, what's the extra cost of this function on average? And it says also what studies or tests have Soltec performed to assume an improvement of 6.3% in a Mediterranean climate? So he's basically trying to say, how do you get clarity on the cost versus benefits? Maybe this is you can start answering the question, but it might be a question best answered offline through an email, I suppose.
Yeah, I mean, I can mention that it depends also on the project, because the size is going to be very important. The number of sensors will vary, and there's the software part that it's going to be for the whole project. So when it's a bigger project, then it will be getting cheaper, right, every time.
Right.
And yeah, well, what the studies or test has performed Soltec to assume, well, we did the validation with that 6.3%. It's not from us, it's from Tube Rayland. They did the validation of the algorithm. We explained to them the algorithm. Then what they did was several scenarios with different latitudes, different regularities of the terrain, and they used the algorithm behavior to simulate those scenarios, and then they came up with that 6.3%. We have a white paper that they can ask us with an NDA, through an NDA, then we can share that white paper.
All right, brilliant. Thank you, Mireia. And Emilio, you clicked on the thing there to share that you want to answer the next question posed by Gonzalo. So, what is a thermal model, and what are the main inputs, and how is it used in PVC's assumptions?
Yeah, I'll do it
over
quickly.
to you.
Yeah, it's very quickly because we don't have much time. But so the thermal model is how PVC models the effect of the wind in the production, the generation. So wind, of course, has a cooling effect on the module. The largest loss of a solar farm is the thermal. It's because of how warm or hot the modules are, which damages the generation. So PV-Syst is not really solving that issue, and they are considering by default 29.0, and this 0 means that it's not taking into account any effect of the wind. So no matter if you have a strong winds, strong enough to cool, not to destroy the plant, but that PVCs will not consider that into account. So what manufacturers or tracker manufacturers are doing is that they will engage and hire external advisors to produce a more realistic parameters for the thermal model. This 29.0 would be can change to, I don't know, whatever, every tracker is different. And then with those parameters, you input those in the PV-Syst, and the PV-Syst will consider the value of the cooling effect of wind, and it will get some improvement in your generation. But you, of course, you need always a third party to validate that in order for the advisors and banks to accept.
Thank you very much, Emilio. And I don't know if anybody else wants to add to this answer. No?
No, I think it was good.
All right, great. So, well, in that case, we have come to the end of our allotted time. So I'd like to thank everybody in the audience and of course, Mireia, Álvaro, and Emilio for being with us today. I think it's been a very insightful session. As I've mentioned a few times, we will send you the recording and the slides as well to your email. So thank you for being with us today. I don't know if you'd like to say anything before you go to the audience. Let's start, from the top. Álvaro, if you'd like to say a few parting words.
Well, yes, I think just as a summary of my presentation is that be careful with the tracker design if you want the tracker to be there for the whole lifetime of the project. And also try to make the tracker smart so you get the most of your tracker and you increase the production and the revenue for your project.
Thank you, Álvaro. Mireia, what are your parting words for the audience?
Well, first of all, thanks for your time. And yes, as Álvaro said, it's important to analyze every tracker with the differences, analyzing also the design and the additional package that can be translated into revenue.
Thank you, Mireia. And Emilio?
For me, well, basically, it's probably the same as my two colleagues said. Also regarding generation and maximizing generation, optimizing, just pay attention, new technologies are coming. And there's never like a recipe that goes for every project. So it's analyzing all of them, and even small improvements will add up. I want to thank you a lot. Thank you very much for ATA for organizing these webinars. I have benefited myself from a number of them. So, I think it's a fantastic thing that you are doing. Thanks a lot.
Well, thank you, Emilio. And with that, we're going to close. If you, if you're there still in the audience, and if you like this type of webinar, you know where to find it. So go to atainsights.com and you'll see all of the webinars that we have to offer. So, well, until next time, thank you very much.
Thank you.